Hey, hello, Matt.
Hi, John. I think it's Thursday.
I think it's Thursday as well. I think it's Thursday here in Europe, beautiful Europe, in Belgium and in Germany. And what is tonight? Tonight is time for
Plastic
Climate
Climate
Future.com.
Future. Oh, yeah.
Boom. We did it again, Matt. That's like
Yeah.
86 times. And our guests, they're still here. Wait, let me get my glasses on to see. They're still here. That's great. That's great. So, Matt,
Yeah.
what do we have
It
tonight?
I think we have a Belgian podcast tonight.
Right.
We have a very Belgian podcast with one boy from Arkansas. And we're super happy to, have two people tonight, which is also not a regular thing in our podcast. We have Steff and Timo from Citribel. And let's say welcome.
Hi. Great to be here.
Welcome.
Hi. Great. So, Citribel, we're going to come to Bell in a minute. I think one thing that I can already disclose is that we're going to talk about a new type, or maybe not so new, but a very innovative and disruptive type of material technologies, and something that John is already looking forward to as well. And first of all, as always, because we at Plastic Climate Future, we also like to feature the people behind innovations that we present here and that we talk about, because it's mostly the people who stand behind them and not the companies. Maybe let's start with Timo. Timo, where are you tuning in from? I already said Belgium. And tell us shortly, what's your background? How did you end up working in Citribel?
So Belgium is definitely correct, in the center of Belgium even. I think I'm 10 kilometers away from Brussels and 40 from Tienen, where I work at Citribel. I started at Citribel 2 years ago, after coming back from Africa, where I stayed 8 years working for my own company that I started with colleagues, an FMCG company. I ended up there from Philips Healthcare, and my professional career started by studying bioengineering at VUB.
Hey,
Now
cool.
taking up this challenging, cool role at the changes that are happening at Citribel.
So bioengineering, there's already some hint what we're going to talk about. Before that, Steph, what's your background?
Right. Yeah, with a background actually as a chemical engineer and a PhD researcher, I was always intrigued actually by recycling, recovery, and upcycling of what was previously considered as a waste product. Nowadays, valuable products. From the concept waste just doesn't exist. And I think Citribel is a very authentic company with this circularity really embedded in its DNA. And the authenticity has a certain charm within the company. However, it offers huge potential with respect to innovation, exploiting even more the circularity in combination with generating added value for the new products or its current product portfolio. And with that respect, since 4 years, I try to bring this innovative philosophy within Citribel as a project manager innovation, identifying and exploring these new development opportunities with a really market-oriented focus.
Cool. That's cool. Oh, Citribel. I've heard of Citribel in Tienen. And just for our listeners, we have 3 or 4 here tonight that are tuning in from Belgium, Matt from Germany. Tienen, east of Brussels, east of Leuven, here in Belgium. And being a bit of a naturalized Belgian myself, when I think of Tienen, I think of sugar. I think of sugar cubes, not the musical group, but the actual sugar cubes. And I think of suikerrock, which is Dutch for sugar rock. So tell us about Citribel, this company, and tell us how it connects to the sugar of Tienen, as one of your raw materials is derived from sugar molasses, I believe. Tell us a little bit more about this.
You have 95% of all the Belgians, when I say I work in Tienen, they say, you work for the sugar company, Sugar Tienen, because that's also their brand name from the sugar cubes. I think they're the most popular sugar cubes in Belgium, so everybody associates Tienen with the sugar company. I always have to tell them no. So first of all, we buy one of the side streams of the sugar factory, being molasses. That's what we buy as our raw material. And then everybody thinks, okay, yeah, so you build your plant next to the sugar factory. That's not the case. That's more by accident, because in, 1919, a young pharmacist did some experiments and wanted to start his own company, and he was looking for money, and he borrowed it from the owners of the Deense Sugar Company. So that's link. And of course, our raw material is a side stream from them, but they don't produce enough of it for us. We really source a lot of molasses from across Europe. So that's definitely the link with Deense Suiker.
Okay. And Citribel, Citra stands for, is it citric acid?
Yes, definitely. So we just recently changed from name, still Citri, Citric from Belgium. Before it was Citric Belge, with the old name. Back in the days, the high society was speaking French, even in Tiene, although it's in Flanders. And I think originally it was a Produit Organique de Tirlemont, it was called. Then they made a joint venture with it to produce this citric acid. And then in 1947, the Italians left and it became a 100% Belgian-owned company. And yes, we are a B2B, so always lesser known to the bigger public. But since I'm in charge of marketing, I'm going to change this.
Yeah, one question then, because we always try to make it understandable for us, which is the level of a drunken 5-year-old. So what can you do actually out of this melasse, and what are typical applications and typical industries that you are delivering solutions to?
It all started from this molasses. We put it on plates. We are the only ones in the world still producing citric acid in this way. I don't think not many companies can say they are truly unique. Citribel has a truly unique production process. So this molasses, it's a sugar side stream. We put it on our plates. We have a lot of plates. Then we throw our mold on it, and then the fermentation process starts. And it will convert the sugar into citric acid. But at the meantime, there's also growing this mycelium. What is mycelium? Yeah, it's the root structure of a fungus, but it doesn't create a fruiting body. So that's the big difference that a lot of people don't know. So we're not growing mushrooms, we're growing the root structure on our molasses together with the citric acid. And of course, it goes to the whole refinery process where we create the citric acid. And in the past, the mycelium was a kind of a side product, and it was just sent to cattle as feed. But luckily, recently, some smart guys in our company thought there's more in this mycelium, we should investigate this. And then it became interesting.
And that's the topic for tonight, because that's how we actually met at the World Biomarkets. And there we dived a bit into the mycelium materials is one potential material class that can replace a lot of other fossil-based materials. But before we dive into it, so you already said mycelium is just the root structure, so it's not the champignon that you eat, right? But you mentioned this was a side stream. So what was what was your main market before that? Was it simply the citric acid that you put in the industry, or did you have also a Citribel that did also have other applications or industries that was delivering solutions to?
Now, the main focus of the company has always been citric acid. That's where the value is. All these other products that are actually considered as a kind of co-product, byproduct. In this case, mycelium is great for cattle feed and still serves the purpose actually for a certain extent as cattle feed. Is nowadays we see actually these great compounds or components in the mycelium with huge amount of opportunities, with great properties, both in materials, but also beyond that.
So how did it come about suddenly? So what was like the eureka moment that you decided, okay, let's do something else than just cattle feed out of that? Was it you when you came to the company and you said, we have here more, we need to do some new project innovations, and came up with this? Or what was the big moment?
I think we had a very smart scientist already within the company who had these great ideas on mycelium and the mycelium properties. This scientist actually wrote down everything in 1989 even, a complete process, completely different applications ranging from materials to as immunity booster or completely different applications. But I think at that time, the world wasn't just ready for these bio products at that time. We dug up a little bit that old material from this scientist at a certain time when I think the company was at that point for these new applications, but also the world in a certain extent.
Yeah, when it comes to Citribel, recognizing the potential value of mycelium, it's my understanding, I've looked onto your website just to try to become a little bit literate in this area. It's my understanding that, number one, Citribel, it says on your website, you're one of the largest producers of mycelium here in Europe, which is really something interesting. And it's my understanding that this is, I think you mentioned earlier, it's a fermentation process where you have a number of plates or trays that you have the sugar molasses placed, and then you inoculate it with your microorganism, which is a fungus, and then this process of microorganism consuming, maybe that's not the right word, but it's doing something with the substrate, and you're producing citric acid, and at the same time, this co-product of mycelium, which is this root structure for that's growing when the microorganism is consuming the substrate. Is that right? Is that what is happening in your process?
Yeah, that's absolutely correct. Now, maybe it's a very interesting question. I think often mistakes are made with a fungus, mushroom, molds, actually. So I think the mistake is often made, I blame pizza fungi, actually, for these kind of things. But what is actually a fungus? If you really dig into the biology, a fungus is actually an organism with chitin in its cell wall. Chitin, a biopolymer, let's say the building block of the cell wall. Within this kingdom actually of fungi, you can find yeast, molds, mushrooms, same kingdom actually. So like Timo already pointed out, what is mycelium and what we're discussing about is the root-like structure of this fungus, consisting of very tiny threads which can be found with mushrooms but also with molds. So now most people indeed know mushrooms as the fruiting body, delicious ingredient of course in many dishes. But the more fascinating is actually what occurs below ground is this huge roots, these threads below ground, the so-called mycelium. And actually the same is actually for molds. For example, molds grown on cheese or in the bathroom, for example. If you look very closely, you see the similar kind of thread-like structure. One major difference, of course, that there's no fruiting body with molds. Therefore, if we are talking about mycelium and mycelium applications, in most cases, we're not talking actually about mushrooms, but we're talking about molds. And similar to having different types of molds, this mycelium, which is actually a quite generic name, you got different types, different species actually of mycelium, with each having its own application. And often, depending on the targeted application, it also has a certain influence on the fermentation technology.
So how does that look like? So you said you have a plate, like just very simple. You have a plate and then some like a mold is growing on it, or what is the consistency? What are like the raw materials that you get out? And I think what is interesting is what are you doing with them afterwards?
Yeah. Now, you have to make the distinction, actually, I already pointed out, the different fermentation technologies. In essence, you have three different fermentation technologies, the so-called solid state fermentation, submerged fermentation, and liquid state fermentation. Now, solid state fermentation is where you grow mycelium on a solid substrate, can be rice husk, can be wheat bran, for example, and mycelium really grows on top, and afterwards is actually cut from the grown medium. Companies, for example, like Ecovative, use this kind of method. Secondly, submerged fermentation. I think the most identified fermentation method is where companies use huge stirred tanks. Mycelium is grown more like in pellets due to the stirring. Think of the most famous brand, Vooren, that some people might eat as a meat replacer, is produced in this way. Again, we're talking about molds. We're not talking about mushrooms. And the third one is actually liquid state fermentation, where mycelium grows on top of a liquid, kind of floats, creating a kind of tapestry like macroorganism. And this fermentation technology allows co-production of several high-value products, but with less energy consumed without active stirring, cooling. And this latter is the more authentic, let's say, fermentation technology that Citribel uses. And also allows, because molasses is a very viscous kind of material, to use this molasses as raw material from the sugar industry in combination with this liquid state or liquid surface fermentation. Indeed, this molasses serves as a cocktail with some added nutrients. We pour it in these huge plates, put them in stacks, put them in a room or these big rooms. And in total, we create by that means 360,000 square meters of fermentation surface, or 50 soccer fields, to give some idea on the size actually. And indeed, our in-house produced spores from this fungus, Aspergillus niger, is actually blown in these rooms. They float on top of the liquid, and that's actually when the magic happens. This mold starts to grow, creating this root-like structure on top of the liquid. And when full grown, it actually starts converting the sugar in this molasses into citric acid. After 8 days of this natural fermentation, resulting in 3 fantastic products: Mycelium, citric acid, and a vinasse, a kind of sugar-free molasses, all with its unique applications, properties, and so on, turning actually a byproduct of molasses into a fantastic portfolio of natural products with a close to zero waste production.
So there is different processes and you use one. And now for the marketing specialist. So what can I do afterwards with it? How do I make money with it? Where do you sell it to? What are the applications? We've heard, of course, carbon footprint. We come to that later. So like sustainable materials, but where exactly? What are your markets and what are your future markets that you think you would be targeting with that?
Like Steff said, we had these ideas on the shelf somewhere with this mycelium, but the focus was so much on citric acid. But then, like you rightly said, making money becomes more and more difficult to make money from citric acid, so we had to diversify. And then we started looking at mycelium because the time was right. We were hearing everywhere people growing mycelium, and yes, we can make some. And they're talking about a kg or something. We produce 22,000 ton a year. It contains 20 to 30% of protein. That's why we were selling it. But why don't we use the other percent, mainly the fibers? So we put on some projects. One of them is, yes, into this material alternatives. Problem is, we are a citric acid producer. We don't know anything about the materials world. Took the strategy going to market with a product very quickly. Then we will learn a lot. We looked into it. Who's interested? It's of course the PU people who want to look for more biological and alternatives. So we joined with them and we made a product called Mycanova, where we blend PU with some mycelium. Is it the best product out there in terms of ecological and recycling? No, not yet, but it allowed us to speak very quickly to the market. And if you don't have a real product, people talk and talk, but they don't give you the real feedback and not the real insight. So we created with partners with existing industrial material quickly a product being Mycanova, which is a blend of PU and mycelium. But within the background, and that's the project we're still working on R&D, is to create a PU-free material, a maximum PU-free material. We're very close there. We already have some samples where we are at 75% mycelium for a material alternative. Being chitin and beta-glucans, mainly beta-glucans, the ones we have, 1316 branched, they're known in the feed market as being immunostimulative. And they only exist today in the market from yeast. So we thought, let's look if ours from mycelium are already also useful. And so we looked into it. We did some tests with very known research centers. And we did some challenge trials with salmon and shrimps. And there our product really decreases the mortality with these people, with these fish when they're under stress. In a couple of months, we launched it already, but the production facility is being built. Then we will launch a product called Mycofence, which is an immunostimulating product for the aquaculture, purified from our mycelium. That's already there for years, and that's the funny thing always. A lot of people suffer with, okay, we have a good idea, we can make something, now we need to scale it up. And I can tell you, scaling up fermentation is not an easy thing. Many startups, but they all fail on the scaling up. We have the other problem, it's already scaled up massively. We just need to fine-tune it and bring it to the market. But we are already thinking in the R&D team further. You can even extract chitin from it into chitosan. Today it exists on the market, mainly made from crustaceans. A lot of problems for allergies for people. Some make it from mycelium with a dirty chemistry and they destroy 80% of the product. It becomes useless due to the treatment. Well, we are working again based on our foundation, we always had a circular process. There's no waste. We only create biological products. We're going to do the same thing with chitosan, where we will keep the beta-glucans and we will keep the proteins. So we are really focusing today on three bigger markets. One is the materials, one is on immunostimulating food market, and one is on chitosan for a lot of other applications.
You mentioned this Myconova brand you created. This is, you say, is initially a blend of mycelium and PU. I assume you mean polyurethane?
Yep, that's correct.
Yeah.
Yep.
Okay. And since, as we're called Plastic Climate Future, we always, certainly I at least have an angle, at least at the beginning, that's coming in through the plastic perspective. And what we're finding with Plastic Climate Future, especially at World Biomarkets recently, is that yes, that's a way into a lot of innovative technologies, but once you get in here, you realize that it's just scratching the surface of the capabilities of these different types of ideas and innovations and technologies, which is here the case with Mycelium. My question is, when I go to your website and I see the process that you show there of getting to the Mycelium, and you at some stage you take your trays, you empty off the liquid, and then you collect the Mycelium layer, and then I believe you wash it, you dry it, and then you mill it into a powder. And that powder is what you're using, if I understand, in combination with polyurethane to make Myconova, which is used in materials that you see, shoe uppers and leather products of all different types. Is that correct?
Fully correct.
Am I right
Well
there?
done. You described it fully correct.
Yeah, and what I was wondering about, I'm going to nerd out here a little bit, is the powder itself. What is the mycelium powder? Obviously has some type of special properties and characteristics that make it where it can replace other materials like polyurethane. Is that due to properties of the mycelium, the structure of the mycelium that's enabling that? Or if not, then I could just use any powdered material to replace something. There's something special there that I'm trying to understand about mycelium that is allowing it to be used as such a material, replacing, in this case, polyurethane.
And that's the trade secret.
All right.
Let Steff answer. There's also there's a difference between the Myconova where we blend it with the PU and the pure product. There we will not go into the powder form, but to do it quickly and to blend it with the PU, we had to go to the powder form. And I'll let Steff answer why it's better than another filler putting it in the PU.
Yeah, absolutely. Now, mycelium, we already pointed out as different compounds in there. We have typically beta-glucans and protein, and we see that there is a very good interaction actually between these compounds and the PU. It's a perfect match, let's point it out like that, which allows us actually to create a kind of product without any quality loss. And that's a bit of a thing in JAM, because we see often these PU replacers on the market, but in the end, the product becomes weaker, and absolutely not our goal. So in this case, the goal was, can we use mycelium as a PU replacer in the first stage, but let's keep this quality and consistency, which is typically required for different applications, shoe or other leather applications. And let's make it in such a way, like you pointed out, John, as a powder, which can be immediately used in the current machinery within the leather production. So these companies nowadays can easily buy mycelium or Myconova powder from Citribel and actually blend it in with their current production, achieving a certain PU replacement, already having a certain impact now, today. But of course, like Timo pointed out, that's not our end goal.
I think you mentioned here something really important, which we should talk about because it's an amazing achievement. It's a natural product that we're talking about here, replacing a synthetic material that has been optimized in terms of properties, that is made of purified materials. And when we come back to the champignon, then you see you're not going to find a box of mushrooms which has always the same size of the fruits in there. And the same here, the challenge is, I think, and this is from my experience with these natural materials, is to achieve this level of quality, of consistent quality over such an amount of material that you're actually producing, right? Where do you see, is this, or do you see this as a main challenge also in general for bio-based materials? And do you think mycelium has here some maybe advantages when compared to other bio-based or renewably sourced feedstocks? What makes it special?
You really point out a good thing where a lot of people struggle with, but we have the advantage that for already more than 100 years, we've been fine-tuning this process of growing this mycelium. That's a lot of time and a lot of knowledge and a lot of experience that we have built over time. The quality right is not an issue for us. That's the funny thing. We don't need to think about this. And we see a lot of other companies with biomaterials struggling with it, but that's really our strong point. These strengths, we can't. We are fixed with the type of mycelium we have also. We can tweak it a little bit, but not very much. So we had to look for other solutions on where we can do it. And we see now that some of our solutions, how we will use it in the material, is the perfect solution to have a good quality and a consistent quality, where others struggles with their consistent quality. From the start, like the luck we had, because we had to do it like this, and also we have this experience to have always the same quality at scale, because that's so difficult for a lot of companies.
What is your dream application where you see mycelium replacing a material from your standpoint or experience point today? Where do you think, we said already, polyurethane, that's something where it can provide a great alternative in terms of sustainability, but probably also in terms of properties. What's your first, maybe Steff, where would you like to see mycelium replacing it? And where do you see it maybe in the future? Like,
now, mycelium has a huge potential. I think we already pointed out in materials, but also I think the main focus in case of Citribel is also this immunity boosting properties that this mycelium can have. It can change a lot within feed industry, food industry, but also chitosan. I think we didn't really point out, but chitosan has many different applications in cosmetics, in pharmacy. This is in some cases considered as a kind of miracle molecule, but still produced in a kind of polluting way. I think what is one major important thing, what we should not ignore, is actually economics. And that's one major thing, in the sense that many companies actually focus on producing mycelium solely for the mycelium, and it puts stress on the economics. It's often not economically viable. And with that respect, if you look at Citribel turning actually a byproduct in 3 different products, that makes it economically viable. And I think we should focus more on the co-production, or the possibilities of co-producing mycelium with other products to also make it economically viable, especially if you look at construction materials or something like that. I think it's a very challenging way, or very challenging to change that industry towards mycelium-based products.
yeah, I can tell you from my experience.
Yes. And economically, people are not willing to pay more for a more ecological product. And I think we know this already. Our goal is, we know it from the start. Like, we can't go to market if we cannot meet the price points the market is willing to pay. And it's difficult, but it's just working harder for us.
Yeah, and especially in the construction industry, it's still driven mainly by cost.
And I think we have this advantage that we don't produce mycelium for producing mycelium. It's already there in combination with the citric acid. And we hope with our mycelium products, yes, we need to grow more. Then we also have more citric acid. But then we need to look for other markets with the citric acid. And then we have other cool projects where we can use citric acid to replace formaldehyde glue also in construction plates, for example. That's going to phase out. And we're working with startups, and like 60% of their new bioresin, it's citric acid. So that again makes the loop complete. Even probably citric acid is playing a role as a binder in the mycelium products for the leather alternatives. So the interconnect.
All right, that's great. Yeah. For me, I'm listening to this and I'm so encouraged by what I'm hearing tonight. Number one, you're like a 100-year-old startup. And I mean that as a compliment because you're not starting up from nothing. You're starting up from 100 years of experience with this stuff. And you're now, over the recent years, learning that, hey, this stuff is really, I look at this and I see market opportunity here.
Very often at the table, Steff and his colleagues and myself, we say, we are a startup within the company because everything was so focused on the citric acid thing. And now we have to go searching on the internet, getting connections on congresses like Bio World Markets to get connections. And really from the start, we cannot rely on colleagues and other people or a legacy in these markets. It's all new and we have to think and work, and we really work like a startup. And that's, I think, what myself and I think Steff also, what we really like about the job we have today.
Yeah. What I see also in common here is like you have an innovative mindset, the two of you, working in a company that has this experience and needs people like you to help stimulate that innovative mindset through the company. And another thing, you mentioned aquaculture. I know some people in the world of chemical recycling, and one of the leaders in the world of chemical recycling is someone who made his name in aquaculture. And so what's interesting is how this frontier of innovation, which is very much also coming to sustainability and circularity, is very much made up of people that are crossing over into the different areas. A lot of cross-pollination or whatever that takes place here. So that's really cool. And something else I just that I'm observing here is indeed I come into this tonight with the plastic part of Plastic Climate Future, thinking of okay, what are we going to do to deal with the issue of the 400 million metric tons per year of fossil-based plastic that's being produced. It's needed in this world, but how do we over time shift away from that? And how can mycelium be a part of the solution? I think that's fair to ask that, and it's important. And at the same time, what I'm learning tonight is yes, but if that's all we look to mycelium to do, we really are undervaluing what we have here. I'm really came into this tonight as a novice. I'm still leaving here a novice, but I see that yes, this mycelium is important for circularity of materials, but it's also important for areas that we will learn more about from Citribel in the coming months and years, perhaps.
And picking up on that, we talked about the sustainability also. Maybe Steff, could you explain a bit more, like what are the CO2 emissions? What is like energy balance or something? Where are the advantages in terms of sustainability with using mycelium, and what does it also compete with? John just mentioned there might be potential to replace fossil-based materials. So what is the carbon footprint, CO2 emissions? What are special things about using mycelium as a material instead of, for example, fossil-based resources?
Yeah. If we look at mycelium, we also have to look at the way it's produced, actually. And I think we already, with respect to this liquid surface fermentation, it's a very unique process and often quite difficult to describe to people who haven't experienced or haven't really seen how it's grown. The advantage of this liquid surface fermentation is that you don't have any stir tanks, these kind of things, pumps, and we actually use outside air as a natural ventilation without disturbing cooling, and that allows us actually to, and with very low energy consumption, grow this mycelium and produce on top of that citric acid. First, it comes to the production of this mycelium. That's the first step. If we then look at the different kind of applications, typically, if we look at PU replacers and Mycanova, we can reduce the CO2 footprint with this current product up to 22% with the current product. So is it the final goal? Let's say it like that. No, but it's the first step we actually wanted to take. And I think Timo also pointed out, it serves perfectly as an immunity booster within aquaculture, for example, but also within human food. If we can decrease the amount of mortality or reduce the mortality actually within this aqua feed, because it will become important within this global world with increasing population. It has a tremendous impact globally.
So it's fair to say that on one hand, it's a low carbon production, but also in the applications that you basically, can use it for, you have more potential to actually save CO2. Does it actually capture carbon during growth also?
No.
Does it require?
Mycelium emits, actually CO2.
Yeah. But our material is sugar beets, and they capture a lot. They're one of the species. Because that's where also, if you look at our citric acid business, like Steff mentioned, the CO2 footprint from the way we produce it is way lower. Unfortunately, nobody's interested in it, but it is a fact. I know people are interested in it, willing to pay a premium for it.
I think as I mentioned, I've been working with this material, and I've seen it in many different applications. And the cool thing is you can actually tune it very easily to have different properties. You mentioned now also food and health products. I come mainly from the material world, so like more industry applications. So that's really an amazing thing, and it's encouraging to see that there is such an interest now, because as I mentioned, I've been in touch with the first innovative, more artist-like applications 10 years ago. And I remember even like listening to this, to the first company that started doing it in the material world and presenting the potential for the material world. I was like, no, it's just hippie. It's not going to happen. The industry is not going to jump on it, and forget about it. And now we're here, and the industry it's an industrialized process, and industry is interested in scaling that up. Yeah, I'm conscious also of the time. And before we come to our most important question, how do you see now actually the interest from the industry, and what did you experience so far? Where do you have interest, in which applications, or where do you see also the drivers in the industry to be interested in your solutions? What kind of players, like, is it like also what was, let's say it like this, what was the most exotic player that from the industry that asked you if you could talk about your solutions or help out with your solutions? Was it, for example, a car maker saying, I want a Mycelium car, or something like this?
Not exotic, but was in the Mycelium and the materials, was for me that the most challenging leather product to make is a steering wheel in a car. If you can make that, you can make everything, because the demands are so high. And if you think about it, it's true. It has to be round, and people touch it with whatever, with sunscreens. But they're really high demanding material people, definitely.
I think, Timo, we had the most funny request we had with respect to the leather alternative that we offer is actually a contact we had, and they had the idea to produce sex swings, actually. So we had the request for the production of a specific type of leather alternative for sex swings.
This can also be demanding.
Ecological, apparently.
Wow, that's really cool.
It's true.
Oh, wow, Matt. Hey, being conscious of the time here, we could go on for a long time here on this. For me, I'm going to need to go away and just let this sink in a bit, which is what I'll do. But what we do here at Plastic Climate Future, as we talked about in the beginning, we recently, for the World Biomarkets event in The Hague earlier this summer, we came up with a tagline to go with Plastic Climate Future. And we say, number one, engaging innovators is our first line. And I would say that we can check the box tonight, Mac, on that. And the second thing we say is seeking solutions. And that's certainly what we're talking about here tonight. For materials, yes, Myconova. But what I'm learning here tonight is, yes, but open your eyes and broaden your horizons, because this mycelium is having huge value in other areas. So seeking solutions, check. And then we have the audacity to say, shaping a better world. I agree with what you say, Timo. People want things to be sustainable. People want things to be better, but unfortunately the market doesn't typically pay for that. At the same time, I think it's up to companies to still work to keep that as one of the values in place, and that is to, at a minimum, to do no harm and to try to apply ourselves to solutions and innovations that are making this place a little bit better. I think that's what you guys are also up to here tonight. So I think we checked all three boxes, Matt, if I can say tonight. And before we close, I think I'm going to turn over to Matt for the most important question that we have tonight.
Yeah. Actually, I wanted to be a rock star, and then my mom, she told me I have to go to university, so that's why I ended up studying chemistry. But I still kept a bit of this passion, and John is also very passionate about music. And it was, a crazy idea when we started the podcast. We said, okay, let's ask every guest that we have about a piece of music that either connects to the podcast or connects to the person. And we so far have quite a big playlist now, and sometimes we listen to it, and it's nice to be getting reminded of, oh, this was this guy, this was this topic, and so on. We cannot let you go before asking also 2 songs from you guys that, is either a good piece of music or something that you like, or something that maybe even connects to the topic here. Maybe Timo first,
should have checked the playlist already up front to see.
Or
I
we
was
can
thinking
tell you.
Knights of Sidonia from Muse, because it's about changing time, fighting for your right to survive, and then the time is now to do it. It could be a good fighting climate change song. There are no songs about Mycelium yet, so I'll talk to some music people.
Plenty of songs that have been inspired by mushrooms.
Yes, that's another type.
And Steff, what about you? Yeah, give us a song.
I'm quite a fan of Michael Jackson, actually, I have to point out. Although I'm quite young, I still have to point out. But
I saw him in concert.
But I really like Earth Song of Michael Jackson, so I will really like to add that to the playlist.
Perfect. I think we had Michael Jackson already, but we didn't have the Earth Song.
We'll add it. We'll add it. I saw Michael Jackson in concert at Rock Vector. It wasn't Rock Vector, it was at Vector. Yeah, and so I was invited by my sister-in-law, who's from Poot, P-U-T-E, which I think Steff is also from Poot.
Yeah.
What a small world we live in. Well, hey, guys, thanks so much for tonight.